Hello everybody and welcome to today's video. I know it has been quite a while, but I have been busy with exams, but now I'm back posting on the channel. And just to let you know guys, I'll be posting even more frequently. You could say every week. I'll try my best. I have a new channel for some other content, but anyways, welcome to today's video guys, and we're gonna be talking about a new topic in differential calculus, and that is gonna be second derivatives. Okay, everyone. So before we talk about second derivatives, let me remind you real quick what is the first derivative. But I won't do a whole summary, because this video is for the people who actually know what calculus is and everything. So if you don't even know what derivatives are, you should go watch my previous videos. So let's say that we have a function y is equal to f of x, and the equation of the line is equal to, let's say something simple. Let's say x cubed. Pause the video and tell me if you can get the first derivative of this function over here. It should be pretty simple, right? So you have a shot. So let's say that y prime of x, and remember the notations, is equal to d dx of x to the third power. So we can simply apply the power rule, take the power down, and then we have a new power, which would be 3 minus 1. So thus our answer here, y prime of x, well, that's going to be equal to 3, bring the power down, x to the 3 minus 1 power, 3x squared. This is a pretty simple idea. We just apply the power rule, and we can apply many other rules for each equation that, the rule that we need, chain rule, quotient rule, and so on. But there is something called higher order derivatives, and the second derivative lies within them. The second derivative is basically taking the derivative of the first derivative. Okay, so this is the notation of it, by the way. You write it like this, dy dx. What is this? This is the first derivative. Notice what happens when I say, like when I write this. Okay, so hold on, this is the first derivative, okay? Okay, so notice the second derivative. Notice the notation of the second derivative. Watch. What changed, guys? What changed? Yes, exactly. This. Where the hell did this come from? Ooh, over here it was a 1. What? But you don't write the 1, do you? There's a 1 here, 1 here. So the clue key in writing these derivative terms, yes, quite literally, it's the number, this number. This represents how many times you've differentiated, because the idea of higher order derivatives is basically the derivatives that are higher than the first derivative. So how many times you differentiate the first derivative. So for example, a second derivative, oh, you've just differentiated the first derivative, well, twice. That's why it's a second derivative. Third derivative, you differentiate it 3 times. Fourth derivative, so on. So we can have a general term for higher order derivatives, and it would be in this notation. Sorry, in this notation, dn, d to the n, y, dx to the n. And yes, you can call this d squared y dx squared, but that's just a notation. So this is our general form of higher order derivatives, d to the n, y, dx to the n. Second derivative, d squared dx squared. Third derivative, d cubed dx cubed. And from squared, you can infer that you've differentiated the first derivative twice. So let's try using, well, the logic we have. Okay, this is pretty simple, alright guys? Don't use derivatives are really cool. Using this logic, I want you just to try to get me the second derivative, right, of this function over here. Alright, and write it in the notation you want. Just give me the equation of the tangent line to this function. Pause the video and try real quick. Alright, I'm assuming you had a shot. So first of all, let's write the notation. Let's write the notation, okay? Okay, I want the second derivative, so d to the n, y, dx to the n. Okay, so let me write it. D, I'm not going to put the n power yet. Okay, dx. So squared, so hold on, I'm going to put a 2 here, right? Because I'm differentiating twice, because it's the second derivative. So hold on, that would be equal to, yeah, hold on, I know this, that would be equal to the derivative with respect to x of the first derivative. Yes, you're differentiating twice. Get it? That's why it's a second derivative. because you've differentiated twice and you've differentiated the first derivative again, right? So using this pretty simple and nice small equation here, I know it's not small, but come on, you're learning calculus. So that's going to be simply equal to d dx. What is the equation of the tangent line here? The first derivative, well, that is 3x squared, right over here. So we are legit going to differentiate this again with respect to x. There you go. So 3x squared. So we can just apply our calculus rules here. I have constant. We'll just put it outside and multiply it by the derivative. Well, that's pretty simple. This is going to be equal to 3 multiplied by dx of x squared. Well, simple power rule. Take the power down. Do the new power 2 minus 1. Well, that is going to be equal to uh, 3 multiplied by 2x. In this case, it's equal to 6x. And we have actually solved it. This is the correct answer for the second derivative of this function y. There you go. That is your final and correct answer. Alright everybody, now that you have seen the question and you know the basic rule, we're going to finish off the video with this pretty simple problem. You might need to remember a few rules, but we'll see what you can do. So we have dy dx, the derivative of y with respect to x. The first derivative, of some function is equal to this. I'd like you to attempt to solve the second derivative. What I want you to get is I want you to get me the equation of the second derivative. So I want d squared y dx squared. Right. Find the equation for this, for the second derivative and tell me what you got. Alright, I'm assuming you've had a shot. So let's see what we have. So first of all, if we want the second derivative, well, we just have to differentiate this little guy over here again. So we have to differentiate this again, like we do. Because second derivative, if it was a third derivative, we differentiate twice, and so on. So we will say over here that d squared y dx squared equal to d dx of what? Hold on. Come on, what's wrong with the d's, bro? Of dy dx, right? That will be your equation. So let's substitute this guy and let's write in 3x squared y. So this can be equal to d dx of 3x squared y. Now, if you want to differentiate this, well, you have a product of two functions over here. We can simply differentiate them using the product rule. First, let us take this constant over here outside and multiply it by the derivative. Well, so pretty simply, this will be equal to 3 multiplied by this whole thing. So product rule, prime of the first one multiplied by the other. Like I said in my video, go watch it. Prime of x squared, well, that's going to be 2x multiplied by y, 2xy, plus the first function x squared multiplied by dy dx, the derivative y with respect to x. It's going to be x squared dy dx. Alrighty, close the fraction. Sorry, we close the bracket. And then we take the 2 over here and we multiply here. So simple algebra here as well. So then that would be equal to 3 multiplied by 2xy, let's do 6xy plus 3x squared dy dx. Now you can close off your equation here, it's fine, but you still have to continue. You gotta simplify it to its furthest. So that would be equal to 6xy plus 3 times x squared. Well, we have to substitute dy dx for what was it equal to? 3x squared y, right? So 3x squared, let's write a different color. So 3x squared y, alrighty? So then all of this will be equal to what again? 6xy plus 3 multiplied by 3, well that's 9 x to the third, x second, x second, less x to the fourth. Right, the powers add them up, same base, and y has nobody to chill with. Well, in this case, this would be the equation for the second derivative, and you can also plot this. I encourage you, actually, guys, don't just write equations in this math. No, actually plot them. Figure out how they are. See at which number the derivative is high. If the slope is steep, it's negative. All of that. Make sure, guys, to like the video, subscribe, and share with your friends so they can also benefit from it. And stay tuned for new videos constantly. And have a good day. Peace.